Hello everyone, my name is Tarun Kumar and now I am going to present my research paper that will be published in Indonesia Journal of Electrical Engineering and Computer Science, that is IJEECS. Now my paper title is Machine Learning Based Emotions Recognition Model using Peripheral Signals, and my paper ID is 38815. I am research scholar, School of Basic Science and Research, Sarda University, Greater Noida, UP, India. Now, these are the content of my research paper. First is abstract, then introduction, method and framework for emotions classification, which we are using for the results and classification, and conclusion, future scope, and in the last reference. Now, abstract. Basically, physiologically signals, these are the physiologically signals RSP, BVP, EMG are the example of physiologically signals. Emotions basically categorize using the peripheral physiologically signals. And we will calculate the accuracy of proposed method along with F1 score. And the proposed method is compared to some recent other study also. And finally, the performance of our suggested technique on deep data set is evaluated. As an input, we are using deep data set that is available publicly for everyone and for the research purpose. Now, introduction. Basically, introduction, brain-computer interface comes from the human-computer interface through which we can interact our brain with the computer. It's a very promising tool for severely disabled peoples, and mostly it is based on EEG signals. Emotions basically is a feeling or state of mind that involves a combinations of different subjective experience, which can be positive or sometimes it may be negative. These are the publicly database which everyone can use, like Deep, Dreamer, Seed, Ambiguous, Safe, and Gambio. EEG signals basically use, or it's a freely available for everyone. Here we are using deep data set as an input signal. So these are the parameter of deep data set. In deep data set, number of participants is 16 male and 16 female. And number of channel is 32. 8 peripheral physiologically signals are available in deep data set. And the name of the signals is EEG, EOG, EMG, GSR, RESP, or BVP, and HST. These are the name of the channels. That is 8 channels are available. And number of videos for each participants is 40. Means everyone have to watch 14 videos and EEG will be recorded. And sample rate frequency is 128 Hertz. And label of data set is 4, that is 4 is valency, liking, arousal, and dominance. And rating is 1 to 9. And quantity for information for every level is 128. And total results a numeric value for each subject. Basically, subject is 32, and now the numeric value for each subject is 40 videos for everyone and 32 channels. And now data is 806. So means a huge data are available for research and using for as a input for any study. Now, methods and framework for emotions classification. This is the model for our proposed emotion recognition. First input, we have to take input signal from somewhere. And here we are using deep data set as an input signal. And then signal preprocessing. After signal preprocessing, we extract the features from the signal preprocessing using the feature extraction method. And after extracting the features, we have to classify and follow the classification process. It can be followed using the classification technique. There are several classification techniques are available. And then in the last final output, and output basically comes from the validation technique. Now these are the steps of for proposed emotion recognition model. Now we will discuss step by step. First is input signal, and input signals we have already discussed. Deep dataset are used as input signals. And point is that we have only used the 4 peripheral physiologically signals out of 8 signals. That is 1, 2, 3, and 4. Now the feature extraction. After getting the input signal and reprocessing, we extract the features. And in this study, the Fisher discriminant approach is used, which is dimensionally reductions algorithm. And Fisher algorithm also help to achieve the main goal of lowering the number of variables. These are the name of the features that is we have already we will extract from the peripheral physiologically signals EMG, GSR, BVP, and RSP. Number of channels and number of features means 5 features extract from these signals and 7 features extract from GSR signals and 13 features extract from the BMP. And the name of the 5 features is that is mean, standards. These are the name of the features. 13 and in the last RSP. Means from RSP we have to extract the 12 features and these are the name of the 12 features. Now after feature extraction, we have a matrix for 32 persons are there and 40 videos there. So suppose we have a matrix that is dimension 32 cross 40. So we have display only the value of 1, 1. And this type of value basically repeat again and again and process basically repeat and again until and in the end that is 32 cross 40. So if we are talking about the first coordinate of this matrix and then the values for EMG, these are the name of the feature and these are the values of these features. EMG basically having 2 channels, channel 1 and channel 2, and then the value of channel 1 and then the value of channel 2. For GSR, these are the name of the features and here for GSR channel is 1. Then the value of this feature is this. Same process basically using BVP and RSP. These are the value of the features for channel 1 and then the name of the features, then the name of the features and then the value of the numeric value of the features. Channel 1, channel 1. So means this is basically this value basically used for the 1, 1 coordinate only, and this process is very repeat and again repeat for up to the 32 cross 40. Means total data basically comes that is 1280 times data recorded for the total matrix. It's a simple calculation. 32 cross 40 means this table basically repeat for 1280 times. Then the feedback value and rating of emotions, labeling and rating, balancing, arousal, dominance, and liking. These are the rating from 1 to 9, and the value is 7.71, 7.6, 6.9, and 7.83. Our classification, after extracting the features, we have to classify. And classifier basically used to categorize the emotions. And there are different techniques to classifications. And a discriminant analysis classifier, basically, which is a Gaussian mixture model for the data protection, is included within the classification discriminant objects. Output and validation. In machine learning and statistical model evaluation, LOOCV methodology is a specialized and thorough cross-validation methods. And it's a technique for determining a predictive model's performance by using all but one data point for training and the only remaining data point for the testing. Means some portion basically used for the training and some portion basically used for the testing purpose. And this is the step for the output and validation. Now the performance metrics, the most often used performance indicator in machine learning and recall precision, accuracy, and standard deviation. F1 score basically is depend on recall and accuracy. In physiologically signal emotions, identification, and the other classification tasks, accuracy is a frequently performance parameter. Here we have to calculate F1 score and accuracy. Then the results and discussion. The findings of the proposed study are compared with the previous work, that is 12, 14, 16 to 17, 22, and 23. And compared to other investigations, these efforts produce the best categorization of valence class finding. Table 6 and 7 show the experiment outcomes that in the context of physiologically peripheral data and the projected algorithm obtain the mediocre recognition accuracy level. The proposed methods basically deep data set and the signals which we are using, and then the results in the numeric value in the percentage for the accuracy and valence. For accuracy, percentage is 80, and for the valencing accuracy is 75.03. If we are talking about the affecting rating, so they are using arousal and valency, but here we are using the four category arousal, valency, liking, and dominance also. Then if we compare and look at the table, so we just find out that the accuracy in our case is higher than the other, which are defined here. Then the comparison of F1 score and accuracy with others reference, that is 23 and 16. If we are talking about the reference 23, the accuracy and F1 score is this. For valency, F1 score and accuracy is this. Liking, accuracy, and F1 score is this. Dominance is not available in this case, and the same process for the 16 reference. But in our proposed method, accuracy is 80%, which is higher than the other. And for the valencing, accuracy is 75, and F1 score is 0.49. For liking, 71, and F1 score is 0.49. And dominance, in case of dominance, accuracy is 78, and the F1 score is 0.47. Conclusion. On the deep data set, the proposed study used for the four peripheral signals such as the GSR, BVP, RSP, and EMG for the arousal, valency, liking, and dominance respectively, and obtain higher classification accuracy of 80%, 75, 71, and 78. In the future, other peripheral signals like SKT, ECG, PPG, and oximetry of plus bio signals can be used for the emotions recognition with different data set for better accuracy and with different combination of classifier along with different and appropriate feature sets. Here, scope is, if we are talking about the future scope, so we just use the different combination for the features extractions techniques and the classifier. And emotions can be classified using other biosensor signals and with the help of machine learning techniques. Now the reference. These are the reference which are used throughout our research paper or throughout our analysis or study. Now that these are the references up to 25. And thank you. Thank you for watching this session and this paper presentation video. Thank you.